Hello, class. Today we're going to learn about center of mass. There are a couple of different ways to find the center of mass of an object. One way is to balance the object on your finger. At the point of where the object balances on your finger is the point of center of mass. Another way to observe center of mass is to toss the object up in the air. As the object rotates in the air, it will rotate about its center of mass. Here's an example of a wrench rotating about its center of mass. Now, whether you knew it or not, so far we've been analyzing all objects at the center of mass when we're solving for velocity, acceleration, force, and so on. Now, mathematically, here's how we solve for the center of mass. The subscript Cm stands for center of mass. So x of Cm is the location of center of mass along the x direction. Notice how big M represents the total mass of Ma plus Mb. In the example below, they demonstrate the center of mass between 2 point particles. If we had a massless rod attached between these 2 point particles, it would balance at the center of mass. And looking at the location of the center of mass, I could tell that mass A is larger than mass B. Now, the center of gravity is a point where the gravitational force can be considered to act. It's the same as the center of mass as long as the gravitational force does not vary among different parts of the object. And we'll use the subscript Cg. Another way to find the center of mass in this example, or center of gravity, which is the same thing, is that you can suspend an object at 2 points. So in this example, the 2 points is the white dot and the black dot. So wherever the object lines up with the point where it's hanging at, just draw a light dotted line, and then do it again at the second dot. And wherever the 2 lines intersect, that's the location of center of gravity or center of mass. Here's our first example. So on a lightweight banana boat, there are 3 people of roughly equal mass m sitting along the x-axis at position 1, 5, and 6 meters, measured from the left hand end. We want to find the center of mass, and we're going to ignore the mass of the boat. The first step is to start off with our new center of mass equation along the x direction. Since all 3 objects have the same mass, I can change all the masses to the variable m, and then I could just factor out m from the numerator. Look what cancels out. Mass. Our equation reduces, and from there we can just plug and chug to get 4 centimeters as our center of mass along the banana boat, which makes sense because the far end is heavier with the 2 people.